All right, ladies and gentlemen, additional problems 6 through 16, waves and sound. Number 6, we have from his bedroom, Garth can hear the distant sound of a train horn as the train travels through the mountains on its way from Chattanooga to Nashville. The horn has a frequency of 800 hertz as the train rolls along at 20 meters per second. What frequency does Garth hear as the train travels away? Important thing to remember about these lovely problems is that you need to make sure you realize who the observer and who the source is. So I'm going to go ahead and observe this or write down that the source is the train and the observer is Garth. So if that's true, let's identify variables. This is my frequency of my observer. If I want to find out what frequency does Garth hear, then this is what I'm looking for. Then I have my frequency of my source. That would be the train. The frequency of the train is 800 hertz. All right. Then we have the speed of the observer. That's 0 because Garth is not moving. And we have the speed of the source. Well, the speed of the source, it's that the train is making its way from Chattanooga to Nashville. And it's traveling through the mountains. So it's moving away from him as it travels away. So since it's receding, we're going to make this a negative 20 meters per second. And then we know the speed of sound is 340 meters per second for these problems that we were doing. So my formula, F prime equals F sub S V plus V naught over V minus Vs. Plug in numbers. I have 800 times my 340 plus 0 over 340 minus a negative 20. And that's going to end up being plus, okay, because a negative or minus a negative is adding. So we should end up with an answer when you actually calculate of 755.56 hertz. That's question 6. All right. Question 7. All right. Question 7 talks to us about Aaron and bells at the hall, in the hall. So our source is going to be the bells, and Aaron is going to be our observer. Let me write O equals Aaron. All right. If that's true, then I know that the source, the frequency of the bells, is 500 hertz each. I know that the frequency that Aaron hears them is what I'm looking for. I know the speed of sound is 340 meters per second. And I know that she is moving towards them at first with 1 meter per second. I also know, so this is my towards, so it's a positive number. I also know that they want me to find as she moves away. Well, that's going to be a negative 1 meter per second when she moves away, because as you recede, it's a negative number, and as you move towards, it's a positive. So again, I have my F prime equals F sub S for my source times the speed plus my V naught over the speed minus my V source. So I have 500 times my 340 plus 1 over 340 minus 0. Sorry, because my Vs, my bells are not moving, they're attached to the wall. I didn't write that. And so then moving towards the bells, she should have a frequency, she should hear a frequency of 501.47 hertz. But moving away, she should have 500 times 340 minus 1 over 340 minus 0 equals, and she should hear them at 498.46 2.53 hertz. So you should have two separate answers, and they should look like this. This one 2 and this one away. All right, moving forward. So I have number 8. Okay. Number 8 talks about Karen flying a plane and Caroline standing nearby and hearing it. And it talks about the frequency of the plane. So the source is the plane. Oops, wrong plane. Sorry. And the observer is Caroline. Karen being involved in the question is just extra information. So if we have our frequency of our source, that would be 200 hertz. And then we have our speed of our observer. Well, Caroline is standing there, so she has 0 meters per second. And the plane is the V source is moving toward her with a positive 18 meters per second, but away from her, it would be a negative 18 meters per second. And then we know the speed of 340 meters per second of the sound in air. We are supposed to, again, solve for F prime equals Fs times V plus V naught over V minus Vs. Okay, since that's the formula, and you've identified everything, all you have to do is plug in information. Again, the most important part of this is that you actually do this. Identify your observer and your sources so that you can get them taken care of properly. Now, for the first one, the toward, she should have 211.18 hertz. And the away or the receding should be 189.94 hertz. All right, moving on. Number 9. Number 9 has a sonar detector, and our sonar detector is working by bouncing a high frequency sound wave of about 100 or 0.1 megahertz. Okay, so that's a frequency. Let's just write it down as 0.1 megahertz, which is really 0.1 times 10 to the 6th hertz. We have a second frequency of 0.101 megahertz, which is 0.101 times 10 to the 6th hertz. All right. And then we know the speed, because we're talking about the speed of water, it tells us is 1520 meters per second. And we have a sub. And it's coming, if a sonar detector receives a return signal of this much from a sub, how fast is the sub moving? So we're actually, the sub is going to be the thing that sends out the actual sound. So that is going to be the source. So we're looking for the source of the sub's speed. So originally the sound sent out was this by the source, and it received it back at this. So that's where I get those. So the source is the sub, and the observer, no, hold on. Did I say that backwards? Yeah. And the observer, no, I said it right. And the observer is the detector. That's right. Okay. So if I am going to use my formula. Oh, sorry. The detector is not moving. It's a 0 meters per second. So I have my F prime equals F sub S times, oops, sorry. Wrote that wrong. Fs times my V plus my V naught over my V minus my Vs. Okay? If that's the case, I have to solve for this variable right here. The easiest way to start this out is to say that you can have V minus Vs equals my F sub S V plus V naught divided by F prime. Then what's going to end up happening is I have to move this over here. So I end up with a negative Vs equals F sub S V plus V naught, oops, divided by F prime minus V. Well, I can't have a negative variable that I'm solving for, so I need to multiply everything times a negative 1. When I do that, that changes this to a positive, that changes this to a negative, and that changes this to a positive. So really the formula should be written as Vs equals F sub S times your V plus your V naught divided by F prime. I wrote it wrong. Sorry. I want to write it this way. So it should be, again, V minus your F sub S, V plus V naught, divided by F prime. If you solve it that way, okay, then you will always get the right answer. So you need to take your 1520, subtract your 0.1 times 10 to the 6th, okay? And then our speeds are our 1520 plus 0, so that's just 1520, divided by our 0.101 times 10 to the 6th, okay? That should end up with your answers. And your answer should end up, as for this one, 15.05 meters per second. Okay? I know, it's a difficult problem. It's a lot of algebra, but you can do it, all right? And the main thing is kind of write this down now somewhere so that once you've done it, you can just use it, okay? Moving on. Number 10. Number 10, we have a fly and a bat. Again, who's the observer and who is the source? Well, the main question says, what frequency would the fly hear? So the observer is the fly. That would mean that the source is the bat. Okay, so I want to find out for 10 what frequency the fly hears. So that's F prime. That's my question mark. So what frequency does my bat give off? Well, as I read the problem, the frequency that the bat emits is a 50,000 hertz. Okay, and I know that the fly is got a speed of 3 meters per second, and he's moving away from the fly, so I have to make it a negative number. Then I know the velocity of the source, or the bat, is 6 meters per second, and it's a positive because he's moving towards the fly. So that's because it's towards, and this is because it is away. All right. So then we also know the speed of sound in normal air is 340 meters per second. So to find F prime, F sub S times V plus V naught over V minus Vs. So we end up with 340 plus a negative 3 divided by 340 minus 6 multiplied by 50,000. When you end up with that answer, you should get 50,449.10 hertz. Again, this is the most important part, is to identify your source versus your observer. Moving on, number 11. Number 11 talks about Lars jogging. So we're still dealing with frequency. And we have how fast is the train moving. So again, who's hearing things? When you read the problem, the observer is Lars. And the source is the train. So F prime, Fs, V, V naught, and Vs, or V of the observer. Let's identify what we know. We know the speed to be in regular air, 340 meters per second. We want to know how fast the train's moving, so that would be my Vs. We know that Lars is moving at 2 meters per second, and it says that the train is behind him, so he's actually running away from the train, so we need to make that a negative number. And then we know that he hears it at 2115 hertz. And we know that it actually blows at 2000 hertz. Okay, I know this. My F prime equals Fs V plus V naught over V minus Vs equals, okay, we want to solve for this. And remember, that's the formula. Vs equals V minus Fs. V plus V naught over F prime. So we have 340 minus 2000 times 340 plus a negative 2 divided by the whole thing by my 2115. When you do your math, you should get an answer of 20.38 meters per second. All right, moving on. We are at number 12. Now 12 is a little bit easier than what we have been dealing with. We have Walter and he has a bass and he has it. We're told that it has a frequency of 82.4 hertz. Millie's a soprano and she can hit as high as a third overtone of this note. All right. So the third overtone is actually the fourth harmonic. So F times the N of the harmonic will give you the new frequency of that harmonic. Okay. So if that's true, then we have 82.4 times the fourth harmonic will give us an answer of 329.6 hertz. The thing to remember is that overtones count the nodes and harmonics count the antinodes. And if you'll just multiply by the number of antinodes, that gives you the new frequency. Okay? Then we're going to move on to number 13. Number 13 tells us that Joy is the church organist and she has a fundamental frequency of 370 hertz. All right. Well, it also tells us that we can get a frequency of, that the first two overtones are 100 and or 1,110 hertz, and 1850 hertz. Well, I want to find out what harmonics these are really, because that'll tell me if it's an open or closed pipe. So I'm going to divide by the original harmonic, and I find out that this is 3, and this is, 70, this is 5. Since this one is 1 and they go by odds each time, this means that the pipe is closed at one end. If it had gone 1, 2, 3, so on and so forth, then that would mean that it was open. All right. So if the fundamental frequency only moves in odds, then it's closed. If it moves in regular whole numbers, then it is open. And this would be an important concept to remember, because if the first two overtones are 3 and 5, then that would mean that it's an closed concept. So I could say that the pipe was closed and ask for the first two overtones, and you're going to need to remember that you go by odds. All right. Then the next one, let's talk about number 14. Number 14, we have a train passes through a tunnel. Well, the tunnel is open on both ends and has a length of, oops, sorry, I don't want to write that. A length of 550 meters. We know sound travels at 340 meters per second normally. And we're asked to find the fundamental frequency. And fundamental means we want to find 1. If we know all this information, we should be able to use the formula via NV over. Since it's a tunnel, it's open. And since it's open at both ends, we use 2L. So 1 times 340 divided by 2 divided by 550 should give me a lovely answer of 0.31 hertz. So the important thing is to remember that it's open, and that's why you use the 2 in this formula. All right. Continuing on to number 15. Almost done. I know it's taking a little longer, sorry. So let's change colors to number 15. Number 15. Again, we are told that we have Harvey the harpist, and they pluck a string that has a length of 0.6 meters. And we are in the first overtone. Well, the first overtone, since it is a harp, it is open. Okay, so the first overtone will just be 2 as the N. And we're told that the frequency at that point is 1046.6 hertz. And we're asked to solve for the speed. Well, again, since it's open, that tells us to use the frequency equals NV over 2L. So 2 times my V, which is what I want to solve for, over my 2 times my 0.6 equals my 1046.6. Really, you could cancel those out, just multiply, and when you solve for V, you should get an answer of 627.96 meters per second. And finally, number 16. Excuse me. Number 16 is beat frequencies, and the formula for beat frequency is the absolute value of the first frequency minus the second frequency. So we're told the first frequency is 293.7 hertz. We're told the second frequency heard is 291.2 hertz. So to find, we're asked to solve for the beat frequency, which is just a subtraction problem. So when we take 293.7, subtract 291.2, you get an answer of 2.5 hertz. Hopefully this clarifies some information for you. That is all 16 problems. Study your waves work or yeah, your waves worksheet that we went over in class. Your review can be looked up, the answers online here, as well as these 16 problems. And your test will be tomorrow or for B days Friday. So good luck. Good evening. Bye. Bye.